responsible for all aspects of the core network, dealing with both the circuit and packet sides, both the wireline mobility as well as the wireline as well as the mobility sides.
Good afternoon. My name is Kevin Mitchell. I'm Director of Solutions Marketing with Acme Packet. We are the leading session border control company and one of the leading IMS equipment vendors in the industry. And my responsibility at Acme Packet is talking about our entire product set and how it applies into various wireless mobile applications and service enablement.
Okay, and I'm Dan Warren. I'm the Senior Director of Technology at the GSMA. The GSMA is the trade organization for most of the mobile industry. We have 800 operators that are members, 200 or so equipment manufacturers, a bunch of carrier operators. And essentially, what we've done for the last 22 years is make roaming work. And beyond that, and since then, we've kind of done a whole bunch of initiatives to generate ecosystems, economies of scale, and drive mobile technology in general, primarily around the GSM family of technologies. But as we move forward towards LTE, with the exceptions of the gentleman who just presented, everybody seems to be on the one roadmap. So if I just launch straight in. What we're going to do now for you is give you about 45 minutes, I think, on voice over LTE. So one of the things around LTE which has provided a lot of discussion points has been the end of CS domain voice. So traditional TDM-based voice doesn't exist in LTE. It hasn't been standardized by 3GPP. Voice becomes a service which is derived over the top as an IP-based service. And that's kind of presented some challenges. There was a video which did the rounds on YouTube probably about 18 months ago with a World War II leader, a German one, and dubbed subtitles over the top about how he wants his 4G CS domain MSCs put out in the network in certain places around Germany. And then when he's told there isn't one, he loses it in spectacular style. One of the things that we're trying to do, though, is do something which is, I guess, taking everything which we have today in CS domain voice and give the operators and the consumers the opportunity to reuse that and continue that service experience. So, and again, with all due respect to everything that the guys from Clearwire just said, one of the most important things that they kind of overlooked around mobile service right now is roaming. And one of the things that makes roaming work is the industry acting together and all using the same technology basis. And then being able to interconnect and interwork across a bunch of well-defined interfaces from home to visited networks, and also being able to interconnect from one network to another on the basis of standards as well. So I make no shame of the fact that I'm a long-term 3GPP standards delegate. I'm one of those guys who's kind of locked in a quiet room somewhere to make sure that all this stuff gets worked out. But then when I'm allowed out, I try and tell people how important it is to have an ecosystem and economies of scale, on the basis that you have to be able to kind of drive devices and drive genuine choice for the consumer market. And then what that kind of drives behind that is the ability for me to be able to bring my BlackBerry device, which is based on the O2 network in the UK, move over here and it connects up to AT&T, it connects up to T-Mobile. I've been to Hong Kong, I've been to Korea, I've been to all these different places all around the world in the last 12 months, and I just turn that on and it works. Equally, I stick my HSPA card in the side of my laptop and that just works too. If you don't maintain that, then suddenly you get a highly fragmented industry, and if the industry becomes fragmented, you take a lot of economy of scale out of devices, which means that driving price points down to a consumer acceptable price point becomes very tough. As we move forward into LTE, small handheld devices are not going to go away. I agree, video is very important from driving data traffic, but sitting on the voice side at the moment, there are $613 billion of revenue per year. Now, $613 billion may be coming under pressure some areas, but it's still no small dice, right? So while the traffic might be 80% about data in the future, it isn't that way on revenue for a very, very long time to come, which means that the voice service has to be maintained and it has to carry on. Why are we actually here talking about it? Why isn't it all just happening? Well, 3GPP kind of left it open, said that we know voice is going to be a data service, but they didn't go as far as actually writing down how it was done. There was an idea that it was going to be IMS-based, it was going to be roughly driven by MMTEL, but nobody sat down and actually write down a SIP profile to make that work. And as a result, some kind of interim or migratory solutions have come up. One is called CS Fallback, where you get pushed out of LTE coverage back onto 2G and 3G, which is good from the perspective of you still get service, but people are finding that it's a bit clunky, and it is widely viewed as a step along an evolution path towards an ultimate solution. Another one is Volga, and Volga sounds great from the perspective that it will use the LTE network, but it suffers from the problem that hardly anybody, only one operator right now is actively supporting Volga as a service, which again is not going to be great if that operator carries on down that path for their customers taking devices overseas, because there's an awful lot of roaming traffic which has got to go back home if you're going to do that, and it doesn't create an economy of scale in the same way as having everybody do the same thing does. And then there was something called One Voice. One Voice came up in November last year. It was defined by 6 operators and 6 manufacturers. But One Voice then looked for a home, and the home was found within the GSMA, and it has become GSMA Voice over LTE. The reason the name changed because One Voice is a great marketing name. Unfortunately, One Voice is trademarked by British Telecom, and they were not overly impressed. So we came up with another name, but this now is adopted by 3GPP, NGMN, IMTC, who are doing some IoT testing. We've pushed stuff out to GCF, PTCRB. It has the support from 20 of the biggest operators in the world, which includes China Mobile, Verizon, AT&T, Vodafone, Telefonica, and I can carry on. That's explicit last February, their support, and there's a whole bunch of others now as well. And all of the major manufacturers as well, including Ericsson, NSN, Alcatel-Lucent, Samsung, HTC, ZTE, Huawei, so on and so forth. So the industry knows where it's going. We're going towards this voice over LTE solution. As I say, it was launched in the Mobile World Congress on the 15th of February this year. The user network interface documentation was published on the 27th of April. It's a public document which I can provide you with the coordinates for if you want it. The NNI for interconnection between one network and another has also been published since June 2010 in a bunch of GSMA documents. And right now we're working on the roaming architecture, and the reason that requires work is that 3GPP define about 4 different options for the functional split between home and visited networks when you roam on IMS. We're in the process of selecting one, which will then be mandated across the industry, and that will be where we move forward from. And once we've done all of that, it's just down to operators, carriers, and vendors to go out and start implementing it. The good news from the perspective of GSMA doing this is that we also take into account the commercial side of this. So we put into place commercial contract frameworks for interconnect and roaming as well. So we get to a point where that ecosystem, which is in existence today for CS domain voice, which has 4 billion connections around it and that $613 billion price tag on it, gets regenerated. So I think that's probably me just about done. What you've got there is a link to the webpage where you can find some of the documentation, a special email address there for voice over LTE. It looks very impressive. I can tell you it comes into the inbox on this laptop here. So if you've got any questions on it, you can email that and I will be happy to answer them. Assuming you don't want to ask questions now, but I'll be happy to answer those at the end as well. So if we leave it at that and we'll move on. I don't know if you guys have got slides too. We'll let Brian come in as well.
Thank you. Okay, I'd like to discuss a little bit now from an operator perspective. What Dan mentioned, most of the activities AT&T has been involved in. From the One Voice perspective, we're members of the GSM Association, VoLTE, we're members of 3GPP, we're members of NGNM. All these groups are involved in looking at one aspect of voice over LTE or another. Just a brief company overview. For those that may or may not be aware of AT&T, we are one of the world's most advanced and powerful Global backbone networks provide over 18.7 petabytes of data traffic on an average business day. Why that's important? Because we do a lot of data traffic today. We have multiple screens of support, everything from our wireless networks to our landline backbone networks to our cable systems. All that data traffic, we're all migrating to a common core network backbone, which includes the IP multimedia subsystem. And we want to make sure that the user experience will be common across all screens. Ultimately, that's the end goal that we're driving towards. As far as our LTE roadmap, we announced in February, Alcatel, Lucent, and Ericsson were chosen as our LTE vendors on the RAN side. We've got LTE trials underway as we speak, and we'll be increasing those throughout the remainder of this year, and we'll have our first planned initial LTE deployments starting next year. Not going to go through the details of this. Obviously, we've got Wi-Fi networks, we've got wireless networks, we do publishing for our directories and so forth, and our broadband network, of course. As far as the evolution to LTE, where we started out was GPRS data, which was a peak of 48 kilobits per second in the past. GPRS data networks still exist today in the network, and they're probably going to exist, coexist with LTE, because LTE rollouts are not going to occur simultaneously worldwide. Edge networks, many operators have upgraded their GPRS to edge with a peak of 237 kilobits per second. When you look at AT&T's network nationwide, we're a nationwide edge operator, so all of our 2G coverage is on edge. UMTS was the next step to bring us up to 384 kilobits per second. And then from UMTS, we went to HSDPA and HSDPA 7.2, and then finally to HSPA Plus, which is being rolled out now to give us a peak at about 16 megabits per second. LTE will come in, starting next year. We'll see it on the AT&T network, and the estimates are there for peaks of 100 megabits per second. When we talk about voice over LTE, as Dan mentioned, LTE itself, there is no circuit switch data within an LTE network. The evolved packet core is just that, a packet core that will supply all services for LTE subscribers, and those services will be rich multimedia services as well as voice services. The Evolved Packet System, or EPS, is the typical name given to the LTE RAN plus the Evolved Packet Core. It's that all-IP mobile network that we'll be developing those services off of. Now, we mentioned NGNM earlier. The operators with NGNM all agree that IMS is the ultimate solution and the foundation for rich multimedia voice data services. Operators are firmly committed to getting to IMS. The question is, when will that be? Different operators are on different timescales to get there. Some of the aspects that Dan mentioned, like CS fallback, are an important step from an operator perspective, because an operator that deploys LTE initially may only deploy LTE data services initially, and the devices may support voice services as well. If an operator doesn't deploy IMS initially, they have to have a way to offer those subscribers the voice services that they're looking for. So that's where CS fallback comes in. And an agreement amongst most operators at this point is CS fallback really has to be the common denominator for providing voice services in an LTE environment. That way, either if a network just supports LTE data services, you can do CS fallback to the 3G or 2G network in order to get voice services, no matter where you roam throughout the world. And that provides, the common core CS domain call control. Some of the other important aspects of LTE voice are single radio voice control continuity, or SRVCC. Once you begin a call on LTE, when you do have the IMS voice available, at some point you'll probably run into a portion in your network where you're going to drop off LTE and need to hand that call back off to 3G or 2G network. Single radio voice control continuity as defined by 3GPP standards allows you to do that. The voice control, call control is still anchored in the IMS after handoff, but it does allow the call itself to be handed back to 2G or 3G network so that the subscriber will maintain that call once you drop off your LTE network. There are various scenarios that can be looked at when you're deploying LTE. The far left-hand side of this shows where you have an LTE data-only service, which many operators will probably be their initial deployments. When you have that LTE data only, if you do have a device that supports voice as well, you'll need a mechanism in place in order to get back to that 3G, 2G voice coverage, and that's known as CS fallback in the 3GPP standards world. The next rollout is when you are able to offer voice services on LTE. You have your IMS in place and can offer those rich voice services. However, your LTE coverage may not be ubiquitous with your 2G or 3G coverage, in which case you'll need single radio voice control continuity in order to get back into the 3G network to hand a call off back into 3G or 2G, as well as CS fallback for those cases where you're actually going to roam into a network that doesn't support LTE voice. And then finally, at some point in the future, LTE voice and data will be nearly ubiquitous with 3G and 2G coverage. At that point, you'll still have single radio voice control continuity, but you'll also still have to have CS fallback in place because that's going to be the common denominator for roaming onto networks no matter where they are. And when you're talking about the GSM family, that could be anywhere in the world. So operators will have different starting points depending on their deployment strategy. Most operators are going to start with the far left of this picture and migrate to the far right over time. And operators have different schedules to when they'll actually deploy IMS-based voice. So with that, let me turn it over to Kevin for...
Good afternoon, everyone. How many of you, when you first started hearing about LTE, actually knew that there would be this issue where really had to think about how voice would get onto this new all-IP network? Is this something that was high up on your list? You know, I certainly realized it, and it was an exciting opportunity for Acme Packet, given that we are all about SIP-based sessions, interactive communications over IP networks. So this is something that we were very excited about once the LT was standardized and started, the rollout plans from operators started. In fact, 2 years ago, or almost 2 years ago, I worked with Carl in creating this very first panel, I think, that brought up and started to discuss this issue. Because rightfully so, all previous LTE or 4G shows were all about the RAN standards and interoperability and the evolved packet core, and now that you're seeing more and more of this as a topic, and we're very excited about it. And for those that aren't familiar with Acme Packet, let me just give a brief introduction. We're a 10-year-old company. We were founded to create the category and the very first equipment called a session border controller, now a pretty well-established piece of telecommunications equipment and networks. We're founded with this mission of enabling the delivery of trusted first-class communications across IP borders. What does that mean? Really, we're all about enabling service providers, enterprises, government institutions to really maximize the opportunity that IP networking and the SIP protocol really can bring about for communications, for services, for revenue opportunities, cost savings opportunities. You know, since founding, we've shipped over 10,000 systems in over 100 countries. We have over 1,000 customers around the world. Profitable company, and some very marquee names are customers of Acme Packet. I think Ryan and Dan have done an excellent job introducing where we've come from in terms of this conundrum of how voice will move on to this new LTE network. There was, again, two years ago or so, we'd be talking a lot more about the options and what the merits are, but you know, I think the industry has clearly spoken. The equipment manufacturers have been talking about this for quite some time, but really what matters was when the service providers voted on the architecture of choice. And that came about November 1st with the One Voice, and then the GSMA follow-up announcement and rebranding in February, in which Acme Packet was also a supporter of that initial announcement of IMS being the chosen architecture for voice in the LTE networks. And you're seeing a lot more traction since that. More organizations have joined up, and in fact, Infinetics Research just surveyed mobile service providers from around the world in the summer timeframe and asked them how they will roll out, or what architecture they'll base their voice offering on. And very clearly, I think all but one said IMS. So maybe we know who that one is, Dan. But you can see there is some other selections of some, probably complementary or out of LTE coverage area opportunities here. But another interesting question that was asked is, and this relates to Brian's points earlier, when will you offer a voice solution once LTE services are launched? And the vast majority, I don't have the chart here, but the vast majority of the respondents said all within 2 years. I think only 10 or 15% were outside that time frame. So voice isn't some far off dream that we're just all talking about to make conferences interesting. It is happening. LTE is being rolled out. That's already underway this year, and voice is going to quickly follow that. So I think Dan did an excellent job kind of outlining what some of those challenges were in terms of how we got the challenges that an all IP network brought about in terms of how you get voice and all those. What was the figure in terms of revenue? Over $600 billion US in revenue. How you get that into this new next generation network? Well, we've again largely solved that problem with the Voice over LTE initiative. But there are some other requirements and challenges that IMS networks, IP networks do present that really this is Acme Packet's expertise. This is why we're around and selling 10,000 systems to service providers and enterprises all around the world, is dealing with these kind of truths, these realities of IP networks. And these truths, and there's many more that we could be explored here, but they do range from things like security, reachability, quality of the communications, the business models that might be implemented in this new world, as well as regulation. So these are the types of things, now that the architecture is chosen, these are the real world challenges that operators are going to need to face. And really what we see, the solution to that is really what we call session, oops, it's on an automatic build here, is session border control. And there's really 5 pillars. You might hear that term, or what's a session border controller? There's really 5 pillars or core functions that there's scores of individual features or even hundreds of little features in each of these 5 areas that really have to do with security. It has to do with SLA assurance or the quality of experience of the communications. Service, what we call service reach maximization, or really fixing and bridging and mediating the differences between networks so you can deliver services to the largest addressable market possible. So that's something like SIP normalization. So vendor A implements SIP one way, vendor B another, vendor C, and you're going to have a multi-vendor network. And yes, SIP is a standard, but a standard is still a set of shoulds, mights, musts. And add that all up in the various ways, and you get different soup that tastes differently, and it might not always work. So also in there is revenue and cost management. There's multiple ways to route calls and get calls from point A to point B in the network, and you need to really do so in the most cost-effective fashion. And then regulatory compliance. Communications are moving to a whole new network, and this has been an issue actually in the news recently with the U.S. government. It's about applying regulations that are all about public safety, public 911 lawful intercept. They have to do with people's lives and moving that into the new form and new forms that we communicate and the new ways in which we communicate. So these 5 pillars of session border control really have a lot of feature depth within them. And what does that mean? What does that translate into Session Board of Control, really what are the value propositions, the ultimate benefits, really take those 5 areas and apply them to these 5 benefits, these 5 value propositions. First, have to do with delivering a high quality of experience to subscribers, and of course that's going to impact revenue growth, subscriber additions, as well as the profitability. Service flexibility, it's really about having the agility and flexibility of the network to address the largest possible market in a rapid fashion. So that's dealing with all those incongruities and differences within networks and protocols and vendors. It has to do with delivering a secure, trusted service. So the network is always up, it's not under attack, serving legitimate subscribers. And in this new IP world, the subscribers are trusting you with those services that you're delivering over this new network. And another important thing, LTE is going to go from thousands to many multiple tens of millions over time frame. So it's about, in terms of subscribers and traffic, and it's about scaling up that service capacity, but doing so, of course, always with an eye on profitability and controlling those costs. And that's what Session Board of Control really translates into in this new LTE world, and for operators to bring IMS-based communications to their subscribers, be they soft clients on a laptop or in handheld mobile devices that we all use today for communications. That's it for my opening remarks, and I think we'll be transitioning to a Q&A now. Thank you.
So what about Q&A, team? Are there questions from the audience before I start up? Dave?
A friend of mine, as I say, is building an LTE network across the state of Vermont. The feds in their stimulus decided they wanted 100% of the state, and he stepped up and is doing it. He's actually got a phone company, local, but not wireless. What would you say to him as his voice strategy to make sure that as he goes forward, needs to be able to interconnect with AT&T and Clearwire and make it work in the back office? What are the big issues he has to think of?
Well, he'll tell you an SPT, which will make all that happen by magic, I expect. In terms of a long-term solution, I think that what we're seeing with IMS is a genuine convergence around voice and in the fixed and the mobile space. So it may not happen tomorrow, but in the longer term, what we're going to get to is certainly people having single subscriptions, which exist for fixed and mobile connectivity. And when I say people, I mean consumers, and possibly even single user identities, single numbers, which go across fixed and mobile and other forms of media as well. So if you're looking at a long-term strategy, certainly IMS is going to be there. And I mean, people have been saying IMS is the strategy for a long time. And like I say, I've been in 3GPP for 8-9 years. I've been writing IMS kind of 7 years ago, and I've been telling everybody that next year is the year for IMS for about the last 6. Where we're getting to now, though, is that you've got the hook to hang IMS on, right? The problem with IMS has always been justifying a business case. And now you've got to do something for voice in LTE. IMS is that solution. It's been there as the latent sleeping giant ready to go. The thing is that the fixed operators are already adopting IMS. There's a whole range of IMS deployments across Europe and North America. They do.
Work with equipment across equipment effectively. There's still a lot of problems there, and that's what I'm trying to.
No, you see, the thing is they do talk to each other fairly effectively. The problem is right now is that IP interconnect isn't sold as a great carrier service. People are pushed back to TDM because that's the voice interconnect technology which people use. And until all of the carrier operators step up and start offering IP interconnect, you're in a situation where you have to go back to TDM. As people kind of move on to IMS solutions and even soft switch solutions on a much grander scale, what we're going to see is a change to remove all of that interworking functionality from IP to TDM at an operator border, which then gets converted back into IP to go across the carrier network, goes back into TDM to interconnect to the operator on the other side. And I'm segueing into another GSMA project here where we've been defining IP interconnection standards for about the last 2 or 3 years, and carriers are starting to adopt them. It's a model called IPX, which reflects the model which we use right now for data roaming in mobile in terms of common set of standards, set of definitions, common commercial principles for interconnect to enable IP interconnect for carrier-grade service to become a reality. And again, my friend here on my left will sell you a box that sits in the middle that makes it all work like magic.
Well, before you do the box in the middle that solves the problem like magic, let's get into the emergency services for a moment. And I've got a very specific question, which is, this is something I know a lot about, and we've got these selective routers, which was the first term we ever used, and to use the word router, and it's truly a tandem, but we'll call it a router from the technology term, that we interconnect to the PSAPs, the local municipalities 911 services, and that's all still TDM right now. What's the plan on migration? Is there any good harmonization going on that when Volt is here that we're going to see the next generation of PSAPs? And does that mean that beyond the voice side of the equation, are we also going to be talking about some sort of other enhanced services? Brian, is that one for you?
I can start. Talk about the U.S. side, and maybe Dan can talk about the global end. That's certainly one of the big issues, is how do you provide emergency services? Because you can't deploy an IP voice network unless you have, access to 911, access to, CLIA, all the regulatory services in place. The National Emergency Numbering Association, or NENA, within the U.S. has defined the next generation 911 architecture, and they've defined what's known as the ESI net, as well as an IP interface into that ESI net. And they recently published their draft, or are in the process of publishing their draft one of their specifications for that IP-based interface. So yes, that is the step in order to get an IMS-based voice network to talk to an IMS or an IP-based 911 network. The problem is the PSAPs are all independent. They each will have to upgrade their own PSAP to NG911 and to the I3 specification, which it's called. And getting them all to do that at the same time is going to be an extreme challenge. From the service provider side, we're going to have the IP-based voice when we launch an IMS-based voice solution. The problem is we may need to convert it back for those PSAPs that don't have their solution in place yet.
Yeah, so from a global perspective, it's kind of, I'm going to be slightly introvert and go back to North America, because the North American operators arrived with a whole bunch of requirements in 3GPP for specifically this problem, and pushed very hard to get a standardized solution included in the first generation of LTE specifications. So that requirement was taken very seriously. It was looked at very closely by all of the other operators around the world who have similar issues. And I think that the global adoption of that as the principle for emergency call is kind of enshrined in what's written down now within IMS specifications relating to voice. In terms of falling back and the evolution of PSAPs towards something beyond TDM or falling back while they go through that process, the good news is that nobody suggests that everybody is going to turn on LTE at the same time. Certainly not everybody is going to turn on voice on LTE at the same time, so you're still going to have a TDM fallback just to make voice calls between an IMS-based voice service and those people who are still on TDM. And as Brian showed on his slides, you're still going to have interworking between IP and TDM within an individual network, because customers are only in 2G or 3G coverage will still be making TDM-based calls as well. So the interworking function back into the PSAP domain is not overly complex over and above the requirements that you need to support traditional interworking to TDM voice anyway. So the evolution is something that happens steadily, but I agree the coordinated change of the PSAPs is probably the biggest challenge.
Cool. Kevin?
Yeah, I mean, within, and Dan alluded to this, within IMS, there's a defined functional element that provides this functions or emergency call support called the emergency CSCF, which sits at the very edge of the network. It's part of the first signaling element that comes into the service provider's network, and it does things like breakout routing. So it excludes that call from any kind of call admission control. So you're not going to get a busy signal when you dial 911. It provides can provide location lookup functions as well. So you're routing it to the proper emergency point, whether PSAP in the U.S. or whatever the appropriate locations are elsewhere in the world. So this has certainly been looked at very early and has been defined. And part of the thing, and I alluded to this a bit about how communications are changing, is what are government bodies going to apply emergency calling to? Could it include things like text-based communications, video telephony, FaceTime type communications? Will subscribers have this kind of expectation that no matter how I communicate, I need to be able to make an emergency call? So that's still a lot of the work that needs to be done too, and is of course out of technology hands. I think the standards groups and technologists can certainly figure out a solution. It's just what are the expectations for it?
Now, a lot of people have been talking about Facebook getting a phone, okay? And I listen to these kind of conversations where all of a sudden it's going to be, Google already went out and made a phone. I bought it and then discovered they didn't want to have me as a customer anymore. It was an interesting experience. Fortunately, it was on your network, Brian, so I had a backup plan. But the question I got is, are all devices going to be equal? Are we going to expect that as a result of being on the LTE network, they're going to have some capability to do some sort of emergency service, or are we going to exclude that? And if we exclude that, that's going to be some interesting definitions going on there. Yes, ma'am.
The standards work that Kevin mentioned, there's a study going on within 3GPP right now called NOVIS, Non-Voice Emergency Services, which is trying to get a handle around this entire situation. There's a lot of push within the U.S. and probably worldwide right now for doing things like SMS to 911. Well, SMS is not a good solution for 911 because it's a store and forward, non-reliable service. So 3GPP is trying to address that and come up with a reliable inherent solution that'll provide non-voice capabilities to 911. Which that network I defined earlier, the I3 interface, as well as the next generation E911 PSAPs will support the ability to receive text, video, what have you. It's just now we at the originating network side have to define the mechanism for getting that information there in a reliable fashion. When you talk about Facebook or any of these other applications, now we're dealing in a realm where you're outside the well-managed network of the operator. So you've got quality of service issues, you've got reliability issues. There's a whole slew of issues that come into play when you deal with your Facebooks, your Twitters, your on and on and on, right, for being able to contact emergency services. And how do you get the location information to those applications in order to route to the right PSAP or to even find you? Hopefully the study within 3GPP will identify all those issues and come to develop a solution that will actually provide a reliable service comparable to when you pick up your voice phone and dial 911 today.
I think as voice and presence and text invade every type of thing that we do and becomes more of a feature and not a service itself, there is a danger that because it's on this network or this provider, it doesn't have emergency service support. There's all these dangerous caveats for the subscriber community, for people, that I think, honestly, the mobile and fixed service providers are well positioned to handle, and that's why there's this fundamental debate, of course, of over-the-top versus the fixed and mobile operators, whether they'll survive. And one of the things, a lot of great assets the fixed and mobile operators have is able to provide these important services to communities. And this federation model that people talk about now and again, this is another example of where that is a service that a fixed or mobile operator could provide to an over-the-top, so that it does have emergency service support, it does have lawful intercept capabilities, and service providers will participate in the revenue stream. There's no caveat around, oh, well, you made a call through over-the-top provider ABC, so that way, it's not guaranteed to go there, or we're going to send it to the wrong place and things like that. So this federation model, there's some enabling technology that needs to be put in place to make it happen, but it's one of the promises of the future, so we don't have to always get into this dumb pipe and the death of the 100-year-old phone company debate anymore.
Yeah. So to kind of take all of those points and turn them around the other way, the GSMA is a big organization which has operators as members, but what we try and do is also try and deal with the reality of the situation, and the reality of the situation is you are going to put a whole bunch of data in the hands of mobile customers on some pretty smart devices, whether they're laptops, smartphones, mids, netbooks, whatever they happen to be, and people will go out and install Skype, and they will go out and they will use Skype on those devices. The difference between a Skype service and an existing TDM service is all the things that you rely on that you don't know you rely on until you really need them. We've touched on emergency services, but there's a whole bunch of other stuff like call hold and call waiting and call user identity, which, unless everybody who's doing an over-the-top service all adopts the same way of doing it, those things are not going to be guaranteed in an interconnected world. So we're not going to say to the consumers, you must do voice this way, and I don't think any operator today can do that right now, particularly not with a whole bunch of net neutrality stuff going on with the FCC. But you do have to give the operators and the consumers the option to have that voice service. Because we're in this room, we are all relatively tech-savvy customers, right? We all know about applications, we all know about broadband services coming online, but my parents want a phone that they punch in the digits and they press the green button and it connects to the person whose phone number they dialed. And they won't care whether it's LTE, HSPA, EVDO, wherever it's Clearwire, WiMAX service. They won't care what the access is. They just want that service. And so it's the perpetuation of that service which is about what we're doing with voice. And the good news with the voice over LTE standard is you can do some exciting stuff on top. You can add on RCS, you can integrate it into applications, but it puts the tools in the hands of the operators to enable that to happen as an addition to the original voice service that they have already. What we're trying to do is just take what you have today and put it into an IP environment, and then where it goes from there is really in the hands of the consumer demand and the operator community as a whole.
Are there more questions from the audience before I start asking more questions, or Dave asks more questions? Yes.
One point that was mentioned was that you were saying that Volt may provide a really good, may be the business case for IMS. Now, during this whole discussion, there's been almost as much discussion of IMS as there is Volt. So is the converse true? In the sense, is Volt dependent on IMS on the back end to be as successful as it can be, or are there other alternatives, or is that not necessary?
So the question is Volt and IMS symbiotic? Do they have to be together in order for the carriers to actually deploy them?
They do, but one of the things which I've put in place in the technical descriptions around this is that there is nothing that says you have to implement IMS a specific way. And again, my friend here will tell you that all the functionality needs to live at the edge. And if you got a guy from Ericsson up here, he'd tell you it's one honking great box that sits in the middle. I don't care. What I care about is that the interfaces that go in and out of that IMS cloud all act the same way, and whether it's these guys' IMS solution or Ericsson's or Alcatel-Lucent's or some combination of all those bits lined up together, make the interfaces open, and that's what drives economy of scale. Coming back to the business case point, like I say, IMS has been around for a long time. You need a big service to justify the investment, and really it's always been about voice. It's just that everybody else has tried to find other ways of justifying it. Push to talk over cellular, it was far too easy to do vertically. The same with some of the RCS type services. Voice needs proper scale, it needs proper functionality. So it's a thing which is going to drive IMS ultimately. It makes me feel good religiously.
Yeah, the other thing I would add is, we have a video share product today at AT&T, which is an IMS-based service on 3G. Okay, so you could say we've launched IMS on our 3G network. Would we ever launch voice over LTE or voice over IMS on 3G? No, we don't believe 3G can handle it. So LTE gives us the data bandwidths that we need in order to provide that voice service. And we see IMS as being the solution for providing the rich communication services that we need in addition to just the plain old vanilla voice services. And it's going to tie all our screens together. You know, when you have your mobile device or your home, home set-top box or whatever, we want to get the services tied together so the users are going to have a consistent experience over them, and that's what IMS will enable for us as well.
So the IMS adoption is pretty, or people are definitely going in the direction of IMS, and it's just a matter of getting interoperability tied up.
Absolutely, absolutely. I mean, we've been kind of, I personally have been tracking IMS for a very long time, obviously. I've been through the peaks and troughs. I don't know if you've ever seen these hype curves. That's my personal life cycle with IMS. I've been through the peak of optimism and through the trough of doubt, and now I'm on the plateau of adoption kind of thing. So I'm right there with that model. The kind of situation has been that even though it's 3GPP that defined it, the fixed guys have accelerated ahead, and people have gone out and deployed IMS-based solutions. I mean, BT21C in the UK was an IMS-based solution, and it's kind of gradually crawling forwards, but people in Telefonica have done some stuff.
Cablevision, most of the cable operators are IMS.
Yeah, there's, I mean, depends on what you define as a project or an institution. I mean, you could carve out China Mobile into 20 different projects. There's somewhere north of 100 projects in installations of IMS. Some might have tens of thousands of subscribers, some have multiple millions, like NTT Docomo's I think push to talk service is completely IMS based, for instance. So there are real commercial deployments and have been for some time. Some of these things have morphed. As we have a good view at Acme Packet because we work with Alcatel, Lucent, Ericsson's, Nokia, Siemens, and Cell as part of their IMS solution. So we get to see a number of installations from that channel reality that we have in terms of getting our product to market. So it's not as growing as rapidly as we would all like, but it's definitely moving along. And what are we working on now? Release 10 in terms of the latest features and updates for IMS. So it continues to move along.
Yeah.
Now,
Okay.
So there's this disconnect of this world that we have right now. Let's just try to figure it out between the three of us, between the three of you. As a former phone company guy, I understand why I need IMS. I've got all these problems down below that, people don't even think about, like how do I generate a phone number to give to people and that kind of stuff. So I need all that integrated services. I've got all these cool apps kids that are sitting there going, just get me into the store and I'll be happy, okay? And I'm sitting there and I'm asking, there's a major disconnect here between the apps happy folk and those of us who have dealt with, deploying a network. And I guess the question for you guys is, are we ever going to see a blend of this, or are we always going to have these two different worlds where the people who run facilities that are based on deployments outside have different issues than the people who are used to running data centers and controlled nice environments?
I have a highly self-serving answer to that, so I'd better let you guys go first.
I think that speaks a bit to my point about federation of, you have a network and a network operator, and you have apps that live out there and get downloaded into the various devices, and maybe there's some server infrastructure that glues all those different downloaded apps together, but it still needs to be transported over a network with quality and also emergency service support and things like that if we get to that point. So I think there's I think there's a lot of groundwork. There's a lot of foundation being laid for this type of federation model, and it could start in an enterprise environment first, or it could come out of a fixed provider environment first. But I think this is something that you're going to see more and more of, and obviously net neutrality plays into this a bit, depending how you define it. But I think there's a lot of interesting possibilities moving forward, and we're just really at a kind of disruption point to shake some things up.
Yeah, you mentioned the enterprise point, and that was one of the So I was going to bring up is I think the enterprise initially will drive a lot of that as well. You know, definitely some of the consumer apps too that we see. You know, and the rich multimedia service environment, the RCS environment, I think is going to come into play and enable a lot of these application providers to get some benefit out of some of the capabilities that the IMS will provide.
Being self-serving for a moment.
Yeah, what I was going to say, I think that as we move forward, voice becomes an application, right? Everything goes away from services, and voice becomes an application that sits alongside everything else. So RCS is another GSMA initiative which is kind of intended to add things like presence and capability exchange and instant messaging, video share, image share on top. Beyond that, GSMA has run a project called One API for some time, which offers the opportunity to draw on network-based APIs for application developers to use information from within the mobile operators, and we're seeing that beginning to gain some traction with some significant trials around the world. And then the really self-serving bit, the wholesale application community, which is this initiative which most of the big operators around the world have signed up to, is kind of intended to do, depending upon how you view it, it's almost like a shim layer that sits between the application developer and the network operator, but to give people the opportunity to use applications across a whole range of different operator communities and a whole range of different platforms. So all those things are kind of coming online. The counterpoint to that, and I guess the kind of reverse to it, is I've seen now RCS applications for Android available, and I've even seen somebody advertising a voice over LTE application for Android. Who they've tested that with, I don't know, because I'm not sure there's anybody out there doing it quite yet. But when people do, that kind of model of doing something which is an open-sourced application platform-driven way of implementing all these services onto devices may be where we go, and it's down to the operator guys to work out where their point in the value chain is.
Good. We have a last question. Was there one over here? Or? Dave?
I wince when I heard you say IMS controlling the video set-top box, because I happen to live in the United States, where the FCC is very serious about the Open Video Initiative, of having a little box at the edge of the home that's cheap as hell, probably doesn't know how to talk IMS, and I certainly haven't seen any of them close to IMS, that is a perfectly fine network interface to your total video service.
Mm-hmm.
How do you make what you're talking about as IMS work with an open video interface connection at the edge of the room, which the cable guys have accepted they'll work with?
Well, yeah, when you're talking about the set-top box, I'm talking about a set-top box that provides a multimedia environment for the subscriber. I'm not talking about just the open video interface, right? We're talking about the set-top boxes that provide the capability to do phone calls, the capability to do messaging, the capability to do other IMS-based services
Yeah, but
from
the
that.
FCC doesn't want you to sell all the set-top boxes.
Right.
That was right in the broadband.
Right,
plan.
but these are supported by the network capabilities and a
If they-
standard interface, right?
Yeah, I hate to say this, but if they can't control Apple being able to isolate me and not allow me to use a different device on the USB, why would I worry a lot? All it says is I've got to create an open interface that says I can match up to other people.
I mean, perhaps the name is the problem, right? So in Europe, we'd refer to something that Brian's talking about as a home hub. It's something which sits in the middle of your home and terminates a honking great broadband pipe, regardless of how it's delivered.